First walkthrough, I chose question number 1, asking about students at a football game. It has a sample mean of 350 and a standard distribution of 25. For the first question, it's asking the probability that more than 400 students will be at a game. So you use this formula to find the z-score, which comes out to 2, and then you have to look on the standard distribution chart, and you have to flip the sign since you're looking for greater there instead of less than, and you get 0.0228, which is the probability that there will be more than 400 students at the game. For question B, it's asking the probability that there will be less than 285 students, and use the formula, and you get a z-score of -2.6. You fill that into the standard distribution probability chart, and the answer for the probability of less than 285 students being at a game is 0.0047. I mixed part D and C up. For part C, it's asking between 350 and 425 students at the game. You have to find each z-score separately and find each p-value for that. For the first one, you get 0 and a p-value of 0.5, and for the second one, you get a z-score of 3 and a p-value of 0.9987, and you subtract them from each other since you're finding the likelihood that it will be between those two things, and your answer for being between 350 and 425 students is 0.4987. For D, it's asking between 300 and 325 students. Again, you find each z-score, -2, which turns out to 0.0228. And for this one, it's -1, which comes out to 0.1587. You subtract the two from each other, and you get 0.1359, which is how many the probability there'll be between 300 and 325 students. And for part E, it's asking the probability that there'll be less than 325 and more than 435, excuse me. And you find each z-score separately and add them together. So this one is -1, which comes out to 0.1587. This one's 3.4, which comes out to 0.0003. Add them together, you get 0.1590, which is the probability there will be between 320 or less than 325 students or more than 435.